Hello, good morning everybody. In previous classes I have already taught you about the chemical kinetics, but I have forgotten to send you the video, so I am again recording it for your revision of chemical kinetics. What is chemical kinetics? I will discuss in this chapter. In class 11 you have might learned about the thermodynamics chapter, especially about the feasibility of the reaction. Feasibility means possibility of the reaction, that chemical reaction which is only possible when the value of delta is negative. That means thermodynamics indicates the feasibility of a reaction, but it does not indicate the rate of the reaction. It is chemical kinetics which tells about the rate of the reaction. For example, thermodynamics data indicates that diamond shall convert to graphite, but in reality the conversion rate is so slow that the change is not possible at all. Experimentally it is shown that there are some factors that influences the speed of a chemical reaction. In class ninth, you have might learned about some factors which influence the rate of evaporation. Here we will study about the factors which affect the rate of the reaction. For example, these factors are nature of the reactants, temperature, catalyst, concentration, particle size, effect of radiation. These factors will be dealt elsewhere. What is chemical kinetics? We can define it. Chemical kinetics is a study of factors that influence the speed of a reaction and mechanism by which a reaction proceeds. Reactions are of two types, that is slow reaction and fast reaction. Slow reaction proceeds slowly. Their rate can be measured by any conventional method. A large number of bonds have to be broken in the reactant molecule and a large number of new bonds have to be formed in the product molecules. For example, inversion of cane sugar, rusting of iron. See the photographs of the rusting of iron. It is very slow process. You cannot observe in a single day. These are too slow to be observed by you in your daily life. Next one is fast reaction. These reactions are very fast. These are too fast to be measured by any conventional method. Therefore, these are measured by special methods. Their half-lives are less than a second. In such cases, there is no need to break the bonds between the reactants, and there is no need to form the bonds between the react products. For example, acid-base reaction. Next one, see the diagrams: burning of fire, burning of goods, or burning of fuel, explosion, etc. These are very fast reactions. Actually, in the case of the solar reactions, it requires breaking of new bonds of the reactant and formation of new bonds of the product. That is why it is very slow. But in the case of the fast reactions, these are already in the form of ions. Therefore, there is no need to break the bond and no need to form the bond. That is why these are very fast. Now, let us see. Define the word rate. Actually, the word rate indicates something is changing with time. When you are going to market to purchase your t-shirt or jeans pant or bat ball, when you return your home, your friends, your parents will ask what is the rate of your t-shirt which you have purchased today. Why they are asking the rate? That means its cost may be increased or decreased with respect to time. That means the rate indicates changing, something is changing with time. Rate is how much quantity changes in given period of time. The speed you drive your car is a rate. The distance your car travels in miles in a given period of time can be expressed in terms of a rate. It is a speed which is a ratio of change in distance upon time interval. Now, in the case of the chemical reaction, what will we change? Their is no change in the cost. Actually, in the case of the chemical reaction, concentration of reactant and product changes, and the concentration of reactant and products are expressed in terms of molar concentration, that is molarity. As the reaction will proceed, concentration of the product will increase and the concentration of the reactant will decrease. But this decrease or change in concentration of the reactant or product is not throughout uniform in same interval of time. Therefore, it is expressed in differentiation form of the mathematical differentiation form, that is dx upon dt, where dx is change in concentration and dt is a small interval of time. Thus, rate is equal to plus minus change in concentration of the reaction species upon time interval. Since the concentration of product increases, therefore plus sign might be used. Thus, rate is equal to change in concentration of product divided by time interval. Similarly, with respect to reactant, since its concentration decreases, therefore negative sign is used. Thus, rate is equal to minus change in concentration upon time interval. Reaction rate changes over time. As the time goes on, the rate of reaction generally slows down because of the concentration of reactant decreases. आप देखे होंगे, जब अगर लकड़ी पर या चूल्हा, कोयले के चूल्हा पर खाना बनाते होंगे तो शुरू में आप देखते होंगे कि खाना बनने का रेट, हीट प्रोड्यूस होने का रेट ज़्यादा रहता है, लेकिन जैसे जैसे टाइम स्पेंड होता चला जाएगा, आगे की तरफ कोयला जलता चला जाएगा, उसका अमाउंट घटता चला जाएगा और लास्ट में आपको खाना बनाना डिफिकल्ट हो जाएगा. So because initially the concentration of the amount of the coal is very large, as it will burn, their amount will decrease, consequently their producing of heat energy content will decrease. Amount of product formed depends on the initial quantity of the reactant as well as on their concentration and chemical reactivity. आपको कितना प्रोडक्ट किसी भी केमिकल रिएक्शन से मिल रहा है यह उसके क्वांटिटी, इनिशियल क्वांटिटी ऑफ द रिएक्टेंट पर डिपेंड करेगा. साथ ही साथ concentration ऑफ रिएक्टेंट पर डिपेंड करेगा, उसका केमिकल रिएक्टिविटी पर डिपेंड करेगा. ज़्यादा रिएक्टिव होगा ज़्यादा प्रोडक्ट बनाएगा, कम रिएक्टिव होगा कम प्रोडक्ट बनाएगा. As the time the reaction stops, at sometimes the reaction will stop either because of reactant run out or because the system has reached equilibrium. जैसे जैसे रिएक्शन अगर आपको आगे की तरफ प्रोसीड हो रहा है तो रिएक्शन आगे रुक सकता है. चाहे तो कब रुकेगा, जब रिएक्टेंट सारा खर्च हो जाए, या when it is in closed container, closed system, then the reaction will achieve the equilibrium position in heat. The rate of forward reaction and backward reaction is equal, which seems to be the reaction is stopped. Let us see some hypothetical reaction of slow reaction and fast reaction. A reaction with a fast rate, a reaction with a slow rate. A plus B gives C. Initially at time 0, concentration of A was 8, concentration of B was 8, concentration of C is 0, and after time 16 seconds, concentration of A is decreased to 4, concentration of B is decreased to 4, and the 4 molecules of products are formed. Similarly, in the case of the fast reaction, initial concentration of X, which is reactant, is 8, and that of Y is also 8, and Z, that is the product, is equal to 0 after time t is equal to 16. X becomes Y equal to 7, Y becomes 7, and Z 1. Then the rate of reaction can be calculated. If rate is calculated with respect to C, that is product of the fast reaction, then we can write rate is equal to del C upon del T, which means change in concentration of the product. What is the change in concentration? Final concentration minus initial concentration. since the final concentration of C is 4 and initial concentration is 0. That means 4 minus 0, and time interval 0 to 16, 16 minus 0. That means it will be equal to 0.25. Now let us see the rate of reaction with respect to reactant A or B. If we are going to calculate the rate of reaction with respect to reactant A, since the concentration of reactant always decreases, consequently negative sign will be used. Thus rate is equal to minus del A upon del T, where del A is change in concentration of reactant within some time interval dt, which implies minus concentration of A2 minus A1 divided by T2 minus T1, where concentration of A2 minus A1 indicates change in concentration of reactant A and T2 minus T1 indicates time interval, since the value of A2 is 4 and that of A1 is 8, which is divided by 16. Thus we get 0.25. Similarly, for the slow reaction, when the rate is determined with respect to the product, then it is rate which is equal to change in concentration of product Z upon time interval del T, which implies Z2 minus Z1 concentration is divided by T2 minus T1. The value of change in concentration of product is 1, to that of time interval is 16. Thus we get the rate 0.0625. Similarly, when the rate of this slow reaction is determined with respect to the reactant A, the minus sign is used, which is rate is equal to this negative sign change in concentration of A upon time interval del T, which implies change in concentration of the concentration of reactant X is 7 minus 8 divided by 16 minus 0. Thus minus 1 upon minus 16 is equal to 0.0625. Now see some other example as I have taught you in previous slide. This rate of reaction at different time interval can be calculated in similar way. You may note this one, how it is calculated with respect to reactant and product for both slow reaction and fast reaction. See another example. At a different time interval, rate of reaction can be calculated with respect to product and reactant as I have taught you in previous slides. Now consider the hypothetical reaction. Red is converted into green. Now here see the data from 0 to 50 second. Initially the number of rate is 100 and it is decreasing from 100 24, 71, 59, 50, 52, 35, 30, 25, 21, 18, and number of blue, that is product, number of red, that is it, that is product, changes from 0 to 16, 29, 41, 50, 58, 65, 70, 75, 79, 82. These data are given. The overall the number is remain 100. In this reaction, the molecule of red turns into one molecule of green. The number of molecules will always total 100. The rate of reaction can be measured as the speed of loss of red molecule over time or the speed of gain of blue molecule over time, that is green molecule. See the graph of conversion of red molecule into green molecule. Since the concentration of a reactant always decreases, it is red. See that this graph, its concentration is decreasing at the time increases and vice versa. Similarly, as you know, the concentration of product always increases. Therefore, as the time will increase, concentration of product will also increase. Now, rate of reaction of conversion of red molecules into green molecules can be calculated. Now, on this graph, on this axis, time is taken, and at this axis, rate of conversion of blue and green. Here, blue is equivalent to green. Must remember, rate of conversion of blue upon time interval of upon divided by time interval. That means rate of formation of green ball, green molecule. As the time increases, rate of reaction decreases. Why so? Due to decrease in concentration of the reactant, reaction rate and stoichiometry. In the most reaction, the coefficient of the balanced equation are not all the same. आप देखते हैं कि मैक्सिमम रिएक्शन में या किसी भी रिएक्शन में कोई जरूरी नहीं कि आपका कोफिशिएंट सबका इक्वल हो. फॉर एग्जांपल H2 plus I2 gives 2HI. Here H2 and coefficient of hydrogen molecule is 1, that of iodine molecule is also 1, and the formed amount of product of hydrogen iodide is 2. It indicates that one molecule of hydrogen combines with one molecule of iodine to form two molecules of hydrogen iodide. Here we can say that coefficient of each reaction species is not equal. The coefficient of reactants are 1 each, and that of product is 2. For these reactions, the change in number of molecule of one substance is multiple of the change in the number of molecule of another. Change करने का जो rate होगा एक दूसरे के substance का multiple होता है. For the above reaction, for every 1 mole of hydrogen molecule used, 1 mole of iodine will also be used, and 2 moles of hydrogen iodide will be formed. Therefore, the rate of change will be different. इसलिए change करने का rate जो होगा उन लोगों का अलग होगा. क्यों होगा? क्योंकि coefficient उन लोगों का अलग-अलग है. In order to be consistent, the change in concentration of each substance is multiplied by 1 upon coefficient. अगर हम लोग जैसे कोई दो बच्चे हैं, suppose कि अनुराग है और निखिल है, दोनों को हम प्लेग्राउंड में दौड़ा दिए, तो क्या दोनों के दौड़ने का रेट इक्वल होगा? नहीं, कोई आगे जाएगा, कोई पीछे जाएगा. ठीक है. सपोज अनुराग 4 रोटी खाता है और निखिल 8 रोटी खाता है, तो दोनों को अगर रेट इक्वल करना होगा तो क्या करेंगे? जो इसका कोफिशिएंट 4 और 8 है, एक दूसरे उसके रेट में डिवाइड कर देंगे. तो जो भी कोफिशिएंट होता है इक्वल करने के लिए हम लोग क्या करते हैं? तो 1 अपॉन कोफिशिएंट कर देते हैं, जिससे रेट इक्वल हो जाता है. आइए हम लोग देखते हैं. फॉर एग्जांपल, फॉर द रिएक्शन ऑफ H2 plus I2, when the rate is retained on the basis of with respect to reactant, then rate is equal to minus change in concentration of hydrogen upon del T. Similarly, it is equal to change in concentration of iodine molecule concentration to that of time interval. But since the number of molecules of HI found just double, therefore its coefficient is 2. Thus, it will be equal to plus 1 by 2 change in concentration of HI upon del T. Average rate. The average rate is a change in measured concentration in any particular time period. It is a linear approximate of a curve. किसी भी कर्व का यह linear approximate होता है, और हम लोग किसी भी टाइम पीरियड में जो रेट ऑफ रिएक्शन मेजर करते हैं, चेंज इन कंसंट्रेशन अपॉन क्या हो गया? टाइम पीरियड, टाइम इंटरवल. तो इस रेंज को हम लोग, उस रेट ऑफ रिएक्शन को ही हम लोग एवरेज रेट कहते हैं. व्हाट इज एवरेज रेट? एवरेज रेट इज द चेंज इन कंसंट्रेशन विथ रिस्पेक्ट टू टाइम पीरियड. पर्टिकुलर टाइम पीरियड में अगर हम लोग रेट ऑफ रिएक्शन निकाल दें, उसी को एवरेज रेट कहते हैं. Larger the time interval, more the average rate deviates from the instantaneous rate. आगे हम लोग देखेंगे कि instantaneous rate क्या है. Actually the rate measured at any moment and instant is known as instantaneous rate, and the rate of reaction measured in a particular time period is known as average rate. The larger the time interval, more the average rate deviates from the instantaneous rate. Now see here, hypothetical reaction, red is converted into blue. Now here time is given in this column, number of red molecules is given, number of blue molecules. Here average rate in 5-second interval. In this column we have calculated average rate in 10-second interval. Here we have calculated average rate in 25-second interval. आइए हम लोग देखते हैं 0 से 5 के बीच में ना, ये कितना पहले 100 था, 5 मिनट के बाद यह 84, 5 सेकंड के बाद यह 84 हो गया. कितने मोलिकुल्स ये मिले? 16 मोलिकुल्स मिल गया. तो 5 सेकंड में टाइम इंटरवल में 5 सेकंड के टाइम इंटरवल में हम लोग एवरेज रेट निकाल सकते हैं. क्या करना होगा, यहाँ पर कॉन्सेंट्रेशन, चेंज इन कॉन्सेंट्रेशन जो है आपका 84 माइनस क्या हो जाएगा 100, ठीक है, फाइनल माइनस इनिशियल अपॉन टाइम इंटरवल से हम लोग डिवाइड कर देंगे तो कितना आ जाएगा आपका 3.2 आ जाएगा. ठीक है, उसी तरह से आप 10 सेकेंड पर निकाल सकते हैं. ये आपका फाइनल माइनस इनिशियल करना होगा. ठीक है, तो 10 सेकेंड पर ये निकालिएगा तो 2.6 आ जाएगा. उसी तरह से 15 सेकेंड में निकालिएगा तो इतना आ जाएगा. आइए हम लोग 10 सेकेंड के इंटरवल पर देखेंगे तो 2.9 आएगा. कैसे आएगा, तो 10 सेकेंड पर ये 100 है, ये हो गया आपका 71. ठीक है, जो चेंज हो गया वो 29. जब 29 होगा और 10 सेकंड पर निकालने हैं तो 10 से डिवाइड कर दिए तो 2.9 आ गया. ठीक है, उसी तरह से हम लोग 10 सेकंड के बाद निकालेंगे. ठीक है, ये 2.1 आ जाएगा. 25 सेकंड पर निकालेंगे तो ये आ जाएगा 2.3. नेक्स्ट 25 सेकंड के बाद ये आपका एवरेज रेट जो होगा 1 होगा. कैसे निकालेंगे आपको बता चुका हूँ निकालने का तरीका, कि rate is equal to change in plus minus change in concentration of a reaction species upon time interval. When time period is taken, then it is known as average rate, and when it is measured at a moment or at a particular instant, then it is known as instantaneous reaction. See in this graph, here H2 combines with I2, then two molecules of Hi is formed. The concentration and time of hydrogen is given. Stoichiometry tells us that for every 1 mole per liter of hydrogen used, 2 moles per liter of Hi are formed. Assuming 1 liter of container at 10 seconds, we used 0.18 mole of hydrogen. Therefore, the amount of hydrogen made is 2 into 0.281 mole, that is, it will be 0.362 mole. जो भी आपका आएगा इसमें वैल्यू आपका H2 के लिए आएगा या I2 के लिए आएगा, जस्ट उसका डबल रेट आप निकाल सकते हैं. डबल कर दीजिए, 2 से मल्टीप्लाई कर दीजिए. ठीक है, तो रेट आपका निकल करके आ जाएगा किसका, हाइड्रोजन आयोडाइड के फॉर्मेशन का. ठीक है, at 60 सेकेंड वी यूज्ड 0.699 मोलिक्यूल ऑफ H2. 60 सेकेंड पे अगर टाइम इंटरवल निकालेंगे तो ये आ जाएगा 0.699 मोल. देखिए पिछले स्लाइड में 60 सेकेंड पर, खैर इसमें अभी नहीं देखा हूँ, यहाँ पर मैं डायरेक्ट लिया हूँ. तो अगर चेंजेस निकालेंगे, ठीक है, 1 में से आप 0.310, तो ये डाटा आपके पास आ जाएगा. तो ये 60 सेकेंड पर हो जाएगा कितना, 0.699 मोल ऑफ H2. Therefore, the amount of Hi made will be 2 into 0.699, that is equal to 1.398 mole. And thus we can calculate the value of hydrogen iodide, rate of formation of hydrogen iodide. The average rate is change in the concentration in given time period. In first 10 seconds, the change in concentration of hydrogen is minus 0.18 mole. So the rate can be calculated. here minus sign is written, which indicates the change. There is decrease in concentration of hydrogen, and फाइनल माइनस इनिशियल आप निकाल दीजिए कितने सेकंड पर, 10 सेकंड पर। तो फाइनल हो गया आपका इतना, इनिशियल हो गया इतना, माइनस कीजिएगा इतना आ गया, ये माइनस माइनस कट जाएगा, आपका इतना आ गया मोल पर सेकंड, यानी 0.0181 मोल पर सेकंड आ जाएगा। आप किसी भी टाइम इंटरवल के लिए ना निकाल सकते हैं, 10 सेकंड पर निकाल सकते हैं, 20 सेकंड पर निकाल दीजिए, 30 सेकंड पर निकाल दीजिए। देखिए आपके सामने ग्राफ दिया हुआ है, डाटा दिया हुआ, उस हिसाब से आप निकाल सकते हैं। ठीक है, तो इस तरह से हाइड्रोजन का निकल जाएगा। आपको रेट ऑफ एवरेज रेट ऑफ रिएक्शन फॉर हाइड्रोजन उसी तरह से हम लोग निकाल सकते हैं, किसके लिए, हाइड्रोजन आयोडाइड के लिए। तो हाइड्रोजन आयोडाइड के लिए जस्ट अभी निकाल करके आपको हमने बताया। उसके रेट निकालने के लिए क्या करना होगा, जो उसका रेट है, देखिए यही ना रेट था आपका। तो इसको निकालने के लिए हम लोग क्या करेंगे, 2 से डिवाइड कर देंगे। तो 10 सेकंड पर निकालना है तो क्या हो जाएगा, 0.362 अपॉन 2 इंटू 10, क्योंकि 1/2 तो कोफिशियंट ही हो गया, और 10 सेकंड के लिए निकाल रहे हैं यानी 20 सेकंड, तो फिर मिला करके इतना आ गया। तो देखिए इक्वल हो गया, रेट ऑफ रिएक्शन आपका इक्वल हो गया। तो रेट ऑफ, चूंकि कोफिशियंट से डिवाइड करने के बाद रेट ऑफ रिएक्शन क्या हो जाता है, इक्वल हो जाता है। तो देखिए सारा डाटा जो है आपका इक्वल आ गया है। आइए हम लोग देखते हैं concentration versus time for hydrogen and iodine, which combines to form 2 molecules of hydrogen iodide. Now this portion I will teach you on tomorrow at 7 a.m.